Hello, today I am going to deal with timers and counters. The timers are those circuits which are going to be used to generate the delay. And the counters are going to be the same circuits which are there in 8051. The same circuit is going to be working for the timer operation and also for the counter operation. And the counters are those which are going to count the external events. So you're going to have basically in 8051 the up counters. You're going to have the up counters wherein these particular circuits, the same circuit, I can make it to work as either timer or I can make it to work as a counter. Okay, so these particular timers and counters, the circuits, what for they are going to be there. As I said just now, they are going to be used to generate the precise time delay. Whenever I want to generate the delays, then I am going to make the circuit, the up counter, to work like the timer, wherein it is going to count the internal clock pulses. It's going to count the internal clock pulses. Suppose if I am making this particular circuit, the up counter, to work like a counter, wherein the counters are those circuits which are going to count the external pulses which are going to come. If you remember, you are going to have T0 and T1 pin in port 3. In port 3, the special function port which we are going to treat, there you are going to have T0 and T1 pin, wherein they are meant to accept the external pulses which are going to come from the peripherals to the microcontroller, and the microcontroller is going to count those particular incoming pulses. Whenever I want to count those pulses, then I am going to use this particular timer and counter circuit which are going to count the external events. Apart from this particular timer and counter circuit present in 8051, they are going to used in generating the baud rates. We know that the special feature of 8051, it is having serial full duplex communication. Whenever I talk about the communication, then the baud rate is going to be the main parameter which we are going to say. It's going to say the number of symbols per second, right? So that particular baud rate can be selected by using this particular timer and counter. So this is why I require the timer and counter. Why I require? The timers are required to count the internal clock pulses in order to generate the delay. The counters are required in order to count the external pulses, in order to count the external events, and it is used to generate the baud rate during the serial communication. Okay, so we'll see the details of this particular timers and counters, and we are going to see some 5 to 6 special function registers which are associated with timers and counters. As I said, the timers and counters are the only one circuit which is going to be the up counter circuit. Okay, so here in 8051 I am going to have two timer circuit. I am going to have two timer circuit wherein we are going to use these particular two circuits, either both as the timer or both as the counter, or one as a timer and another as a counter. It all depends. Okay, so the counter or the timer requires some count to be loaded, in the register. So in timers and counters, so in 8051 you are going to have two 16-bit registers. You are going to have two 16-bit registers, timer 0 and timer 1. I am having two timer circuits. I am going to have two timer circuits, and in order to load the count either for the timer operation or for the counter operation, I am going to use these particular 16-bit registers. What are those? These are timer 0 and this is going to be the timer 1. These are 16-bit registers. These two are made up of two 8-bit registers. It is made up of two 8-bit registers, TL0 and TH0. Timer 0 is made up of two 8-bit registers, TL0 and TH0, and timer 1 is made up of two 8-bit registers, TL1 and TH1. See, it is made up of two 8-bit registers. Each of the 8-bit register is going to be the special function register, and it is having its own address. TL0 is having address 8A hex. TH0 is having 8C hex. Similarly, TL1 is having 8B hex, and TH1 is having the address 8D hex. Like how accumulator is having E0 hex, register B is having F0 hex. Like that, TL0, TL1, TH0, TH1 are having their own addresses. Why I need these particular register timer 0 and timer 1? Whatever the count I want to load, so that the content of these particular registers will be up counted whenever I start the timer operation or the counter operation. The change is going to be in these particular registers only. So the count which I want to load initially, that will be loaded in TL0, TH0, TL1, TH1. Either I can go for T0 or T1. I can use both in the same program, both as a timer or both as a counter, or one as the timer and another as the counter. There is no such restriction that you have to make them either to work only as a timer or only as a counter. You don't have such restriction. So these are going to be the two special function registers which are required in order to load the count in these particular registers, so that whenever the up counting takes place, the content of TH and TL, that is going to get changed. Up count is going to be taking place. Okay, now I said that they are going to count which one? Suppose if I make the timer to work like timer, then it is going to count the internal clock pulses. I said that it is going to count the internal clock pulses. Okay, now we'll discuss little bit about the internal clock pulses. See, we know that I can have a crystal connected to 8051 right from 1 megahertz to 16 megahertz frequency. So the internal clock pulses are going to be generated with the help of that particular crystal oscillator. Okay, so now the time taken by an instruction, it is going to be called as machine cycle. It's going to be called as machine cycle. It's a minimum time which is required to execute a simple instruction. That is going to be called as machine cycle. Okay. So the machine cycle, maybe some instructions may take 1 machine cycle, few instructions may take 2, or the other may take 4 even. Okay. So what does it mean? See, why the machine cycle length is getting varied? The length of the machine cycle depends upon how the data is being fetched, which type of addressing mode it is using, how the source is specified and how the destination is specified. Depending upon that, the number of machine cycle is going to get varied. Say for example, move A, R0, it's going to take only 1 machine cycle. Whereas the complicated ones, say the multiplication, the division, those are going to take more machine cycles. It's going to take 4 machine cycles like. So it all depends upon how I am going to specify the source operand and how the destination operand is going to be specified and what operation is being performed. Depending upon that, the number of machine cycles are going to be decided. Now coming back, one machine cycle consists of 6 states, and each state will be equal to 2 pulses. It is going to be equal to 2 pulse, wherein that I am going to call it as T states. One T state will be equal to 2 pulse. That means this one is going to be 1 T state. 2 pulses are there. So it's going to be called as the 1 T state, and it is having 2 pulses. One machine cycle includes 6 T states. It's going to include 6 T states. That means there will be 12 pulses in it. Right? Now if I want to calculate the frequency, what we are going to do is, since I am going to have the 12 pulses, I am going to divide the given crystal frequency by 12. Okay, so that's what I have written over here. Just now I said the timers are those which are going to count the internal clock pulses, So what's going to happen? The clock frequency which is available for the timer operation, the internal clock frequency, it is equal to crystal frequency divided by 12. Crystal frequency may vary from 1 megahertz to 16 megahertz. Whatever they have given, for that particular frequency I have to divide it by 12, wherein it is going to give me the timer clock frequency. If I want to calculate the time, then just take the reciprocal of the value, then you are going to get the time period over there. Okay, so this is going to be about the timer 0 and timer 1 special function register and the machine cycle information. See, this particular timer or the counter, they can be controlled with the help of this particular timer mode register, TMOD register, that is timer mode register, and one more is there, that is TCON register, timer control register. First let me discuss about the TMOD register and then we'll go for the TCON register. Timer mode register, timer mode register. So this particular register is going to help the programmer to select the different modes of the operation, and as I said, the same circuit can be made to work either as a timer or as a counter. So in order to select whether I want to perform the timer operation or the counter operation, you are going to have the control over here. The selection bit is going to be over here, where it is going to help me in selecting the counter operation or in selecting the timer operation. Okay, and you can also have over here the selection of, see, whenever I load certain value in T0 or T1, then if I want to start the operation, whether it is a timer operation or the counter operation, whenever I want to start, whether that particular start should be software controlled or whether it should be hardware controlled, that bit also is going to be there in the TMOD register. Have in mind, this particular TMOD register is going to help me in selecting the mode of operation, whether it is going to be the software control or the hardware control, whether I want to select the timer operation or the counter operation, or what kind of timer counter operation, which particular mode you want to select, that is going to be present in TMOD register. And the address of the TMOD register is 89 hex. It is going to be the byte addressable register. It's a byte addressable register. Even TL0, TH0, TH1, TL1 all are byte addressable. That means I have to load the byte. I cannot, if I want to change a single bit, then I cannot select that particular bit and I cannot change it. So that's why I'm going to call it as byte addressable. This is byte addressable. Okay. So this particular TMOD register is a 8-bit register which is byte addressable, wherein the bits which are present in the TMOD register, all the 8 bits are going to have special function assigned to it. Each bit is going to have special function. So what is this? You can just see over here. See here, it is a 8-bit register. Okay, the higher nibble, it's going to be for timer 1, because I have two timers, right? So timer 1, and the lower nibble is going to be for timer 0. It's going to be for timer 0. So whenever I want to select any operation for timer 1, then I have to change the content of the higher nibble, and whenever I want to select any operation for the timer 0, then I have to change the content of this particular lower nibble. Whatever you change, you have to load a byte in the TMOD register. Okay, fine. Now, let me write. So here the bit is going to be the gate. This is going to be gate control bit. Next one, C/T bar. And these are the mode select bits, M1, M0. This is going to be for timer 1. The same bits are there for timer 0. That means it's just the replica. That is, this is the gate, this is C/T bar, this is M1, and this is going to be M0. You can see over here the same 4 bits are there for timer 0 and the same 4 bits are there for timer 1. Okay. Now, this particular gate if it is 0, if the gate is equal to 0, if the gate is equal to 0, then I can start the timer operation or the counter operation just by using the instructions. Just by using the instructions, you are going to see in the TCON register timer run bits. Those particular run bits are going to be set or reset, and that is going to help me in starting the timer operation or the counter operation. So if the gate is equal to 0, then it is going to be the software control. It's going to be the software control. That means by using the instruction, I can start the timer operation or the counter operation, or it may be the serial communication even. So if the gate is set to 1, if the gate is set to 1, then it is going to be the hardware control. I'm going to have a switch. I'm going to have a switch wherein I have to press that particular switch. Then the timer or the counter operation is going to begin. If I want to give the example, in the stopwatch, it's a stopwatch. Say, ಯಾವುದೋ ಕಾಂಪಿಟೇಷನ್, ರನ್ನಿಂಗ್ ಕಾಂಪಿಟೇಷನ್ ಆದ್ರೆ 1, 2, 3 ಅಂತ ಟೈಮರ್ ವಾಚ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ. ಅದನ್ನು ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಪ್ರೆಸ್ ಮಾಡ್ತಾರಿಲ್ಲ. That means it's a hardware control. Same here, if the gate is equal to 1, then it is going to be hardware control, and if the gate is equal to 0, then it is going to be software control. Hardly we are going to prefer the hardware control. We usually prefer the software control. That is gate. The same is going to be, the explanation is going to be same for the timer 0 even. Okay, now coming over to the next one. See, we are having the same circuit, a single circuit. The same circuit is going to be made to work like a timer and also the counter. What is timer? Timer is the one which counts the internal clock pulses. Counter is the one which is going to count the external pulses which are going to come on T0 and T1 pin of port 3. Right? So if I want to make the circuit to work like a timer, ಆ ಸರ್ಕ್ಯೂಟ್ ನಂಗೆ ಟೈಮರ್ ನಂಗೆ ವರ್ಕ್ ಮಾಡಿಸೋದಿತ್ತು ಅಂತಂದ್ರೆ ಈ ಬಿಟ್ ಒಳಗೆ ನಾ 0 ಬರಿಬೇಕ್ರಿ. C/T bar, you can see over here T bar ಮುದ್ದ ಬರ್ದಿರೋದೇ. T bar ಅಂತಂದ್ರೆ ಏನು, ಲೋ ಆಕ್ಟಿವೇಟೆಡ್, ಅಂದ್ರೆ ಟೈಮರ್ ಸೆಲೆಕ್ಟ್ ಮಾಡೋದಿದ್ರೆ ಇಲ್ಲಿ 0 ಇರಬೇಕು. 1 ಇತ್ತು ಅಂತಂದ್ರೆ ಕೌಂಟರ್ ಆಪರೇಷನ್, 1 ಇದ್ರೆ ಕೌಂಟರ್, 0 ಇದ್ರೆ timer operation. Coming over to the next one. These are the mode select bits. These are the mode select bits. So this is very, very important. It is going to help me in deciding how much delay or how many pulses you want to count. You can put the limitation over there, whether you want to have the short time delay or greater than that or the biggest one. So that particular selection can be done over here with the help of the mode select bits. Even you mode select bits, mode 1, mode 0. This is M0, M1. These are the mode select bits. If this is 0, 0, if this is 0, 0, then it is going to be called as mode 0. Mode 0. If both the bits are 0, 0, then ಯಾರು ಬರೀತಾರೆ, ನಾವು ಬರೀಬೇಕ್ರಿ. We are going to select, because ಎಷ್ಟು ಡಿಲೇ ಜನರೇಟ್ ಮಾಡಬೇಕು ಅಥವಾ ಎಷ್ಟು ಎಕ್ಸ್ಟರ್ನಲ್ ಇವೆಂಟ್ಸ್ ಬರ್ತವೆ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ಗೆ T0 ಮತ್ತೆ T1 ಪಿನ್ ಮೇಲೆ ನಮಗೆ ಐಡಿಯಾ ಇರ್ತದೆ. ಸೊ ಅಕಾರ್ಡಿಂಗ್ಲಿ ಐ ಹ್ಯಾವ್ ಟು ಸೆಲೆಕ್ಟ್ ದ ಮೋಡ್ ಆಫ್ ಆಪರೇಷನ್. ಸೊ ಇಲ್ಲಿ 0, 0 ಇತ್ತು ಅಂತಂದ್ರೆ ಇದು ಯಾವ್ದಿದು, ಮೋಡ್ 0. ಮೋಡ್ 0. ದಿಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ 13 ಬಿಟ್ ಟೈಮರ್. ಇಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ 13 ಬಿಟ್ ಟೈಮರ್. 13 ಬಿಟ್ ಟೈಮರ್. ಏನ್ 13 ಬಿಟ್ ಟೈಮರ್ ಅಂತಂದ್ರೆ, ಸೇಮ್ ಈಗ ಟೈಮರ್ ಆಪರೇಷನ್ ಯಾವುದೋ T0, T1 ಯಾವುದೋ ಒಂದು ರೆಜಿಸ್ಟರ್ ಒಳಗೆ ಸೇಮ್ TL0, TH0 ಇವು ಎರಡು ರೆಜಿಸ್ಟರ್ ತಗೊಂಡಿನಿ. ರೆಜಿಸ್ಟರ್ ತಗೊಂಡು ನಾ ಇಲ್ಲಿ ಏನ್ ಲೋಡ್ ಕೌಂಟ್ ನ ಲೋಡ್ ಮಾಡ್ತೀನಿ, ರೈಟ್. ಸೊ ಯಾವ್ದನ್ನ ಅಪ್ ಕೌಂಟ್ ಮಾಡ್ಬೇಕು ಅಂತ ಅಂತೀನಿ, ಆ ಕೌಂಟ್ ನ ಏನ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲಿ ಲೋಡ್ ಮಾಡ್ಕೋಬೇಕು. ಲೋವರ್ ಬೈಟ್, ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಲೋಡ್ 1FF0 ಯಾವ್ದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ತಗೊಂಡಿನಿ, 1FF0. ಸೊ ಇದು ಲೋವರ್ ಬೈಟ್ ಅದ, ಇದೇನದ ಹೈಯರ್ ಬೈಟ್. ಸೊ ಲೋವರ್ ಬೈಟ್ ಇದ್ದಿದ್ದು TL0 ದಾಗ ಹಾಕೋಬೇಕು. ಲೋವರ್ ಬೈಟ್ ಏನದ F0, ಹೈಯರ್ ಬೈಟ್ ಏನದ 1F ಅದ, ಇಲ್ಲಿ 1FTH0 ದಾಗ ಹಾಕೋತೀನಿ. Anyone, yeah, either you can take T0 or T1. Just for example, I am taking TL0 and TH0. TL0 ದಾಗ ಏನು ಹಾಕಿನಿ, F0. TH0 ದಾಗ ಏನು ಹಾಕಿನಿ, 1F ಹಾಕಿನಿ. Okay, when I start the timer operation, then what's going to happen? The content of TH0 and TL0, ಇದು ಯಾವುದು, ಫಸ್ಟ್ ಇದು ಚೇಂಜ್ ಆಗ್ತದೆ, ಲೋವರ್. Okay, so this digit is going to get changed with every clock pulse, falling edge. Okay, with every clock pulse ಏನಾಗ್ತದೆ ಅಪ್ ಕೌಂಟ್ ಆಗ್ತದೆ. ಅಂದ್ರೆ 1F F0 ಇದಿದ್ದು ಪಲ್ಸ್ ಬಂದ ತಕ್ಷಣ ಏನಾಗ್ತದೆ F1. ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂದ ತಕ್ಷಣನೇ F2. ಸೊ with every clock pulse this will start up counting. ಇದು ಎಲ್ಲಿ ತನಕ ಕೌಂಟ್ ಮಾಡಬೇಕು ಅದನ್ನ ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಹಾಕೋದು ಈ ಮೋಡ್ ಸೆಲೆಕ್ಷನ್. ಓಕೆ, ಸೊ ಎಲ್ಲಿ ತನಕ ಕೌಂಟ್ ಮಾಡಬೇಕದು ಅಂತನ್ನೋದು ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಹಾಕೋದು ಈ ಮೋಡ್ ಸೆಲೆಕ್ಷನ್. ಮೋಡ್ 0 13 ಬಿಟ್ ಟೈಮರ್ ಅದು. 13 ಬಿಟ್ ಟೈಮರ್ ಅಂದ್ರೆ ಎಲ್ಲಾ 13 1 ಆಗೋ ತನಕ ಎಣಿಸ್ತದೆ. 13 1 ಅಂದ್ರೆ ಎಷ್ಟು? 1 F F F. This is going to be the 13 bit. You can see over here F is 4 1. 4 plus 4 plus 4 12. 12 plus 1. This is going to be 13 bit. This is going to be 13 bit. So ಇದು ಅಪ್ ಕೌಂಟ್ ಆಗಿ ಎಲ್ಲಿ ತನಕ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್ ಆಗ್ತದೆ? 1F FF ತನಕ ಕೌಂಟ್ ಆಗ್ತದೆ. This is going to be 13 bit timer. ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂದ್ರೆ ಏನಾಗ್ತದೆ? ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂತು ಅಂತಂದ್ರೆ ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್. 13 ಬಿಟ್ ಟೈಮರ್ ಒಳಗೆ ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್. 1F FF is the maximum count. ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂತು ಅಂತಂದ್ರೆ ಏನಾಗ್ತದೆ? ರೀಸೆಟ್ ಆಗ್ಬಿಡ್ತದೆ. ಲೈಕ್ ಹೌ ಈಗ 1 2 3 4 5 6 7 8 9 ಆದ್ಮೇಲೆ ಮುಂದೆ ಎಣಿಸ್ರಿ ಅಂದ್ರೆ 0. isn't it? It's going to be 0. So maximum count reach ಆಗಿ ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂತು ಅಂದ ತಕ್ಷಣ ಈ ಕೌಂಟ್ ಏನಾಗ್ಬಿಡ್ತದೆ? 0 ಆಗ್ಬಿಡ್ತದೆ. ಮತ್ತೆ ನಾನು ಸೇಮ್ ಆಪರೇಷನ್ ರಿಪೀಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಮತ್ತೆ ನಾ TL ಮತ್ತೆ TH ದೊಳಗೆ ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಮೊದಲು ಏನು ಹಾಕಿದ್ನಲ್ಲ, ಏನ್ ವ್ಯಾಲ್ಯೂ ಹಾಕಿದ್ನಲ್ಲ ಅದನ್ನ ಮತ್ತೆ ಹಾಕ್ಬೇಕು. ಅಂದ್ರೆ ಅಷ್ಟೇ ಡಿಲೇ ಕೊಡ್ತದೆ. ಬೇರೆ ಕೌಂಟ್ ಹಾಕಿದ್ರೆ ಅಂತಂದ್ರೆ ಬೇರೆ ಕೊಡ್ತದೆ. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಥಿಂಗ್. ದಿಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಮೀನಿಂಗ್ ಆಫ್ ಮೋಡ್ 0. ಇದು ಎಷ್ಟು ಬಿಟ್ ಟೈಮರ್? ಇದು 13 ಬಿಟ್ ಟೈಮರ್. 0 ಹಾಕಿದ್ರೆ 13 ಬಿಟ್ ಟೈಮರ್. 13 ಬಿಟ್ ಟೈಮರ್ ಅಂದ್ರೆ ಏನು? ಇಟ್ ಕ್ಯಾನ್ ಕೌಂಟ್ up to maximum 1F FF. 1F FF. With each and every falling pulse, it is going to up count. It's going to up count. Up count ಮಾಡಿ maximum count reach ಆಗಿ ಮತ್ತೆ pulse ಬಂತು ಅಂತಂದ್ರೆ ಇದೇನಾಗ್ಬಿಡ್ತದೆ? roll over ಆಗ್ಬಿಡ್ತದೆ. It is going to become 0. Okay. Now, next one is going to be mode 1. Mode 1, what it is? This is going to be 0 1. It's going to be 0 1 ಅಂದ್ರೆ M0 ಬಿಟ್ ನೊಳಗೆ 1, M1 ಬಿಟ್ ಒಳಗೆ 0 ಬರದೆ ಅಂತಂದ್ರೆ this is going to be mode 1 operation. And it is going to give you the biggest delay, the highest delay in the 8051. This is going to be 16 bit timer. It's going to be 16 bit timer. 16 bit timer ಅಂತಂದ್ರೆ ಎಲ್ಲಿ ತನಕ ಕೌಂಟ್ ಮಾಡಬಹುದು? FF ತನಕ ಕೌಂಟ್ ಮಾಡಬಹುದು. FF hex ತನಕ ಕೌಂಟ್ ಮಾಡಬಹುದು 16 ಬಿಟ್. ಅಂದ್ರೆ ನಾ 1F F0 ಹಾಕಿದ್ದೆ ಅಂತಂದ್ರೆ ಈ ಮೋಡ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ವಿತ್ ಎವ್ರಿ ಫಾಲಿಂಗ್ ಎಡ್ಜ್ ಪಲ್ಸ್ ಬಂದಾಗೆಲ್ಲ ಏನ್ ಮಾಡ್ತದೆ? ಕೌಂಟ್ ಮಾಡ್ಕೋತ ಹೋಗ್ತದೆ. 1F F0 F1 F2 ಹಿಂಗೆ ಎಣಿಸಿ ಎಲ್ಲಿಗೆ ಹೋಗ್ತದೆ? FF ತನಕ ರೀಚ್ ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂದ ಮೇಲೆ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ರೋಲ್ ಓವರ್. ಇಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿಕಮ್ 0 ಯಾಕಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್ ಎಷ್ಟದದು? FF. ಓಕೆ, ಸೊ 1F FF ಗೆ ಕೌಂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು? FF ರೀಚ್ ಆಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು? ಜಸ್ಟ್ ಯು ಕ್ಯಾನ್ ಇಮ್ಯಾಜಿನ್. ಸೊ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಜನರೇಟ್ ಅ ಡಿಲೇ ವಿಚ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದ ಮೋಡ್ 1. ಸೊ ನನಗೆ ಹೈಯೆಸ್ಟ್ ಡಿಲೇ ಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ನಾ ಮೋಡ್ 1 ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಇಲ್ಲಪ್ಪ ಅದಕ್ಕಿಂತ ನಂಗೆ ಕಡಿಮೆ ಬೇಕು ಅಂತಂದ್ರೆ ಐ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಮೋಡ್ 0. ಓಕೆ, ಸೊ ಹಿಯರ್ ಅಗೇನ್ ಈಗ ಇದೇನಾಯ್ತು? FF ರೀಚ್ ಆಯ್ತು. ಇಲ್ಲಿ ಹೆಂಗೆ ಹೇಳಿದೆ ನೋಡ್ರಿ, 1F FF ರೀಚ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬಂತು, ಏನಾಯ್ತು? 0 ಆಗ್ಬಿಡ್ತು. ಮತ್ತೆ ಅದೇ ನನಗೆ ಮಾಡ್ಬೇಕಾಗಿತ್ತು, ರಿಪೀಟ್ ಸೇಮ್ ಡಿಲೇ ಜನರೇಟ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತು ಅಥವಾ ಸೇಮ್ ಇವೆಂಟ್ ನಾ ಮಾಡ್ಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಮತ್ತೆ ಇದು TL0 TH0 ದಾಗ ಏನಾಗ್ಬಿಟ್ಟಿರ್ತದೆ? ಈಗ 0 ಆಗಿರ್ತದೆ. ಸೊ ಮತ್ತೆ ಅದೇ ಬೇಕು ಅಂತಂದ್ರೆ ಇನಿಷಿಯಲ್ ವ್ಯಾಲ್ಯೂನ ಏನ್ ಹಾಕಿದೆ ಅದನ್ನ ಹಾಕ್ಬೇಕಾಗ್ತದೆ. ಸೊ ಇಲ್ಲಿನೂ ಹಂಗೆ 16 ಬಿಟ್ ಟೈಮರ್ದೊಳಗೂ ಹಂಗೆ FF ರೀಚ್ ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬರೋಣ ಏನಾಗ್ತದೆ? ರೋಲ್ ಓವರ್ ಆಗ್ತದೆ. ರೋಲ್ ಓವರ್ ಆಯ್ತು ಅಂತಂದ್ರೆ TL0 ಮತ್ತು TH0 ಕಂಟೆಂಟ್ ಏನಾಗ್ಬಿಡ್ತು? 0 ಆಗ್ಬಿಡ್ತು. ಮತ್ತೆ ಸೇಮ್ ಆಪರೇಷನ್ ನಿಮ್ಗೆ ರಿಪೀಟ್ ಮಾಡೋದಿತ್ತು ಮತ್ತೆ ಸೇಮ್ ಡಿಲೇ ಜನರೇಟ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಇನಿಷಿಯಲಿ ನೀವೇನ್ ಕೌಂಟ್ ಹಾಕಿದ್ರಿ TL ಮತ್ತೆ TH ದೊಳಗೆ ಮೊದಲೇ ಏನ್ ಹಾಕಿದ್ರಿ ಅದನ್ನ ಮತ್ತೆ ನೀವು ರೀಲೋಡ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ. ಅದನ್ನ ರೀಲೋಡ್ ಮಾಡ್ಲಾರ್ದೆ ಹಂಗೆ ನೀವು ಮತ್ತೆ ಆಪರೇಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ದ ಕೌಂಟಿಂಗ್ ವಿಲ್ ಬಿಗಿನ್ ಫ್ರಮ್ 0. ದ ಕೌಂಟಿಂಗ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿಗಿನ್ ಫ್ರಮ್ 0. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್ ಮೋಡ್ 2. So this is going to be 1 0 mode 2. This is going to generate the smallest delay. It's going to generate the smallest delay. It is 8-bit timer. This is just 8-bit timer. It is 8-bit timer. 8-bit timer. ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್ ಎಷ್ಟು FF ಅಷ್ಟೇ. ಸೊ ಏನೇ ಕೌಂಟ್ ಹಾಕ್ರಿ ಕೌಂಟ್ ಹಾಕಿದ್ರೆ ಎಲ್ಲಿ ತನಕ ರೀಚ್ ಆಗ್ತದೆ FF ತನಕ ರೀಚ್ ಆಗ್ತದೆ. FF ಆಗಣ ಮತ್ತೆ 0 ಆಗ್ಬಿಡ್ತದೆ. But the speciality of mode 2 is no need to reload the initial value. ಹೆಂಗ್ mode 0 ಮತ್ತು mode 1 ಒಳಗೆ ರಿಪೀಟ್ ಮಾಡೋದಿತ್ತು ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಹೆಂಗ್ ಹಾಕೋಬೇಕಾಗ್ತಿತ್ತು ಹಂಗೆ ಇಲ್ಲಿ ಹಾಕೊಳ್ಳೋದು ಜರೂರಿ ಇಲ್ಲ. No need to reload the initial value. Automatically reloading facility is there in mode 2. Okay, so this particular mode 2 is going to be used preferably in the serial communication. In order to generate the baud rates and all, you are going to prefer the mode 2. ಯಾಕಂತಂದ್ರೆ ಕಡಿಮೆ ಟೈಮ್ ದೊಳಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಿಟ್ಸ್ ನನಗೆ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಅಥವಾ ರಿಸೆಪ್ಷನ್ ಮಾಡೋದಿರ್ತದೆ. ಸೊ ಐ ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ದಟ್. ಸೊ mode 2 it's a 8-bit timer with auto reload facility. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, ಬರೀ TH ದಾಗ ಅಷ್ಟೇ ವ್ಯಾಲ್ಯೂ ಹಾಕ್ತೀವಿ. TH ದೊಳಗೆ ಅಷ್ಟೇ ವ್ಯಾಲ್ಯೂ ಹಾಕ್ತೀವಿ. ಯಾವಾಗ ಟೈಮರ್ ಅಥವಾ ಕೌಂಟರ್ ಆಪರೇಷನ್ ಸ್ಟಾರ್ಟ್ ಅಂತೀನಿ, TH ದೊಳಗೆ ಏನದ ಅದ್ರದ್ದೊಂದು ಕಾಪಿ TL ಗೆ ಹೋಗ್ಬಿಡ್ತದೆ. ವಿತ್ ಎವ್ರಿ ಪಲ್ಸ್ TL ಕಂಟೆಂಟ್ ಚೇಂಜ್ ಆಗ್ತದೆ, TH ಕಂಟೆಂಟ್ ಒಟ್ಟ ಚೇಂಜ್ ಆಗಂಗಿಲ್ಲ. ಸೊ TL ಯಾವಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್ ರೀಚ್ ಆಗಿ 0 ಆಗ್ತದೆ, ಈ TH ಏನ್ ಮಾಡ್ತದೆ ಆಟೋಮೆಟಿಕಲಿ TL ಗೆ ಮತ್ತು ಒರಿಜಿನಲ್ ಏನ್ ಡಾಟಾನ ಲೋಡ್ ಮಾಡಿದೆ ಅದನ್ನ ಕಳಿಸ್ತದೆ. ದಟ್ ಈಸ್ ದೇರ್ ಇನ್ ದ mode 2. ನೆಕ್ಸ್ಟ್ ಒನ್ 10 mode 3, wherein this particular mode 3 is going to be used in 8052. Anyway, we are going to have again a 8-bit timer only. Timer 0 ಏನದೆ, that is going to be TL0, and the TH0 is going to be controlled by the timer 1. Okay, so don't think about that one. 8052 we are not going to use it anyway. So mode 0, mode 1, mode 2. Mode 0 13-bit timer. It can count from 000 to 1F FF. Mode 1 it is 01, it is a 16-bit timer. From 0 to FF it can count. With every clock pulse falling edge, the up counting is going to take place. Mode 2, it is going to generate very smallest delay. It's a 8-bit timer. It's having auto reloading facility. Fine. This is going to be the TMOD register. It's a 8-bit register. It is byte. We'll go for the next SFR which is connected with timers and counters. T0, T1, TMOD. All the three are required. Timer 0 16-bit register is required to load the count. Right. T1 is required to load the count. We are going to load the lower byte in TL and higher byte in the TH corresponding to T0 or T1, whichever I want to use. And TMOD is must because I have to select the mode of operation. I have to select how to start, whether the software control or the hardware control, and I have to select the counter operation or the timer operation. So I require T0, T1 and TMOD. So the next one, it is the timer control register. TCON register. This particular TCON register is a 8-bit register. It's a 8-bit register and it is bit addressable, unlike to TMOD. TMOD is byte addressable, whereas TCON is bit addressable. It is bit addressable. That means I can use set the bit, clear the bit instructions, either to set a single bit or to clear it. Okay, that is going to be the meaning. That is bit addressable. Timer control register. Okay, the address of this particular SFR is 88 hex. It is 88 hex, and all the 8 bits present in this particular 8-bit register are having their own addresses. You can see over here the LSB bit, the 0th bit, is having address of 88 hex. The next bit is having 89. The third bit is having 8A. Like that, MSB bit is having the address of 8F hex. Either I can take only one bit, I can change the content, or I can make it 0 or 1, whatever is required, or as a whole also I can load it. How I can load the data in the TMOD register? Just by writing move TMOD, comma, whatever the value you want to load, you can write it over there. So this is how you are going to load the value in the TMOD register. Similarly, you can use move TCON in order to write the value, or else since it is providing me the facility to load the bit also, I can directly go for a particular bit and then I can change the content of that one. So that is bit addressable, that is timer control register. We'll go to this one. See, TMOD register, TCON register, PSW, program status word. These are going to be the important SFRs wherein you are going to get the question in your question paper one or the other way. So you should have in mind how to write the bit pattern for that and what's the explanation for each and every bit, because if it is an SFR then each bit is going to have its own function. Fine. Timer control register. You can see over here the lower nibble is connected with the interrupts. It is connected with the interrupts, which I am going to deal in the next class. That is interrupts. And the higher nibble is connected with the timer or the counter operation. So the higher nibble is connected with the timer or the counter, and the lower nibble is connected with the interrupts. So first let me explain about the timer or the counter higher nibble, and then we'll see interrupt lower nibble. Okay, we'll see this one, what it is. You can see over here, you're going to have the 4 bits wherein TR0, this is timer run bit 0. This is for timer 0. This particular bit is meant for timer 0. For timer 1, you are having TR1. Okay, this is also timer run bit 1. What for these are going to be used? These are used to start the timer or the counter operation, or to stop the timer or the counter operation. You are going to use these particular TR0 and TR1 to start the timer operation or the counter operation, or to stop those particular operations you are going to use. Right? How I am going to use this one? If I make the bit status equal to 1, and if I make the bit status equal to 1, then the timer or the counter operation of timer 0 will begin. 1 ಮಾಡಿದೆ ಅಂತಂತಂದ್ರೆ the timer operation is going to begin, or the counter operation is going to begin. If I make it as 0, then it will be stopped. Then it is going to be stopped. Fine. Timer 1, for this particular timer 1, to start the timer or the counter operation, I am going to use this particular timer run bit 1, wherein if I make 1 in this particular bit, if I write the status as 1, then it is going to start the timer or the counter operation connected with timer 1. If I make it as 0, then it is going to stop over there. So how I am going to make it as 1 or 0? That is by using the instruction set the bit yadu TR0. If I am using timer 0, I am going to write TR0. If I am using timer 1, then I am going to write set the bit TR1. ಯಾವುದು ಟೈಮರ್ ನಾನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀನಿ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮರ್ ರನ್ ಬಿಟ್ ಅನ್ನೇ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು, ಅದನ್ನೇ ಸ್ಟಾಪ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಹೆಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಿ ಆಪರೇಷನ್ ನ? ಸೆಟ್ ದ ಬಿಟ್ TR0, ಸೆಟ್ ದ ಬಿಟ್ TR1. ಇಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಾರ್ಟ್ ದ ಟೈಮರ್ ಆರ್ ದ counter operation. Okay, in order to clear it, in order to stop it, then I have to make it 0. That is, I have to clear TR0 or TR1. Then it is going to stop the timer or the counter operation. Timer or the counter operation can be. So timer run bit are going to be set by the user, and it should be cleared in order to stop it. Okay, now we'll move on to the next bit which is present over here. That is TF0 and TF1. What are these? These are timer 0 flag bit. Timer 0 flag bit and timer 1 flag bit. So this particular flag bit is connected again with T0 and this is connected with T1. This is connected with T1. Okay, here what's going to happen, see we have seen the different modes of operation. In TMOD, if it is 00, then it is a 13-bit timer. It's going to count up to 1F, FF, and if it is a 16-bit timer mode 1, then it is going to count up to FF, FF. If it is mode 2, then it is going to be a 8-bit wherein it is going to count up to FF. In each and every mode, when the maximum count is reached, then with the next pulse, the rollover takes place. That's what I have said in all while explaining TMOD register. Maximum count tanka up count akkota hogtude. Maximum count reach admele next pulse admele enagtude rollover agbidutade andre enagtude 0 agtude. So a 0 adaga some indication should be there to the programmer that the timer operation is finished or the counting has reached the maximum value. So in order to indicate that, in order to inform the programmer, the status of the flags are going to be read. Which are those flags? For timer 0 there is one flag, that is TF0, and for timer 1 it is TF1. See, when the counting is going on, that means from whatever count we have loaded in T0 or TF1, when we start the timer using TR0 or TR1, when we start it, up counting begins. And depending upon the mode, it is going to reach the maximum value. When the counting is going on, then the status of the flags will be equal to 0. That means if I read the status of the flag is 0, then I have to understand that still the counting is going on. Still the maximum count has not been reached. But once when the maximum count is reached and with the next clock pulse, what's going to happen? Rollover takes place. When the rollover takes place, these particular flags which I am using, T0 or T1, that particular flag will get set to 1. That means it is automatically set by the machine, by the controller. It is set by the processor. Okay. So, yaವಾಗ ಇದನ್ನ 1 ಅಂತ read ಮಾಡ್ತೀನಿ, 1 ಅಂತ read ಆಯ್ತು ಅಂತಂದ್ರೆ ಏನು, maximum count reach ಆಗಿ roll over ಆಗ್ಬಿಟ್ಟದೆ, 0 ಆಗ್ಬಿಟ್ಟದೆ. ಮತ್ತೆ ನನಗೆ ಸೇಮ್ ರಿಪೀಟ್ ಮಾಡೋದಿತ್ತು ಅಂತಂದ್ರೆ ಮೋಡ್ 0 ಮೋಡ್ 1 ಇದ್ರೆ ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಕೌಂಟ್ ನ ನೀವು TL ಮತ್ತೆ TH ದೊಳಗೆ ಹಾಕ್ರಿ. ಮೋಡ್ 2 ಇತ್ತಂತಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ತಾನೇ ರೀಲೋಡ್ ಮಾಡ್ಕೋತದೆ, ಮತ್ತೊಮ್ಮೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೋರಿ ಅಂತಂತಂದು ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಟ್ಟೆ. So these are the flags whose status is going to say whether the timer operation or the counter operation is in process or whether it has finished. That is what we are going to understand. It is going to be set by the processor, but it should be cleared by the programmer. So these are going to be the TR0, TR1 timer run bits, which we are going to use to start the timer and to stop the timer. TF0 and TF1, these are the flag bits which are set by the processor when the operation is finished, when the rollover of the maximum count takes place, and it should be cleared by the programmer before the programmer repeats the process again. So this is going to be the higher level of TCON, which is going to provide us the control. That's why timer control register. So this is going to be about the higher level. Coming over to the lower nibble. So again here in the lower nibble, as I said, it is connected with the interrupts. See, we are going to have two external interrupts. INT0 pin ade elli port 3 ದೊಳಗೆ INT0 ಮತ್ತೆ INT1. ಹೆಂಗೆ ಬರೀತೀವಲ್ಲಿ ಪಿನ್ ಫಂಕ್ಷನ್ ಹೇಳಬೇಕಾದ್ರೆ ಏನು ಹೇಳಿದೆ? INT0 ಬಾರ್, ಇಟ್ಸ್ ಅ ಲೋ ಆಕ್ಟಿವೇಟೆಡ್ ಪಿನ್. ಅದನ್ನು ಲೋ ಎಷ್ಟೋ ತನಕ ಲೋ ಇರ್ಬೇಕ್ರಿ? 4 ಮಷಿನ್ ಸೈಕಲ್ಸ್ ತನಕ ಅದೇನಿರ್ಬೇಕು? ಲೋ ಇರಬೇಕು. ಅವಾಗ ಮಾತ್ರ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ದೊಳಗೆ ನಾ ಇಂಟರಪ್ಟ್ಸ್ ನ ಎನೇಬಲ್ ಮಾಡಿ ಇಟ್ಟಿದ್ದೆ ಅಂತಂದ್ರೆ ದ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ವಿಲ್ ಐಡೆಂಟಿಫೈ ದಟ್ ದೇರ್ ಈಸ್ ಅನ್ ಇಂಟರಪ್ಟ್. ಇಂಟರಪ್ಟ್ ಬಂತು ಅಂತ ಹೇಳಲಿಕ್ಕೆ ನನಗೆ ಒಂದು ಫ್ಲಾಗ್ ಬೇಕಾಗ್ತದೆ. I need a flag which is going to indicate that there is an interrupt. There are two external interrupts, INT0 and INT1. So for INT0, I am going to have the flag interrupt edge flag 0, and this is going to be interrupt edge flag 1. Okay, so what these bits are going to say, ಯಾವಾಗ ಇಂಟರಪ್ಟ್ ಬರ್ತದೆ ಲೋ ಆಕ್ಟಿವೇಟೆಡ್, ಲೋ ಇದ್ದಿದ್ದ ಸಿಗ್ನಲ್ 4 ಮಷಿನ್ ಸೈಕಲ್ಸ್ ತನಕ ಲೋ ಇತ್ತು ಅಂತಂತಂದ್ರೆ ಈ ಫ್ಲಾಗ್ ಯಾವ ಪಿನ್ ಮೇಲೆ ಬಂದಿರುತ್ತೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ಲಾಗ್ ಸೆಟ್ ಆಗ್ತದೆ. ಫ್ಲಾಗ್ ಸೆಟ್ ಆಯ್ತು ಅಂತಂದ್ರೆ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ವಿಲ್ ಕಮ್ ಟು ನೋ ದಟ್ ದೇರ್ ಈಸ್ ಅನ್ ಇಂಟರಪ್ಟ್ ಆನ್ INT0 ಪಿನ್ ಆರ್ ಆನ್ INT1 ಪಿನ್. These are the flag bits. Right? They are set by the processor and cleared by the processor. Okay. Now, next one, it is about the interrupt triggering. ಅಂದ್ರೆ interrupt ಯಾವಾಗ ಬಂದಿದೆ ಅಂತ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ಗೆ ಗೊತ್ತಾಗಬೇಕು, ಅದನ್ನ ನಾವು ಸೆಟ್ ಮಾಡಬಹುದು. ಹಾಗೆ ಲೋ ಲೆವೆಲ್ ಇತ್ತು ಫಾರ್ 4 ಮಷಿನ್ ಸೈಕಲ್ಸ್ ಅಂದಾಗ ನಾನು ಐಡೆಂಟಿಫೈ ಮಾಡ್ಬೇಕು ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ಅಂತ ಅಂದೆ ಅಂದ್ರೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಬಿಟ್ಸ್ ದೊಳಗೆ 0 ಬರಿಬೇಕ್ರಿ. ಅಂದ್ರೆ ಲೆವೆಲ್ ಟ್ರಿಗರ್ಡ್ ಅಂದ್ರೆ ಲೆವೆಲ್ ಯಾವುದು 0ನೇ, ಯಾಕಂತಂದ್ರೆ ಇವು ಲೋ ಆಕ್ಟಿವೇಟೆಡ್ ಅವ. ಲೋ ಲೆವೆಲ್ 4 ಮಷಿನ್ ಸೈಕಲ್ಸ್ ತನಕ ಇತ್ತು ಅಂತಂತಂದ್ರೆ then these particular bits are going to have the status of 0. ಯಾವುದು ನಿಮಗೆ IT00 ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಲೆವೆಲ್ ಟ್ರಿಗರ್ಡ್, ಲೋ ಇತ್ತು 4 ಮಷಿನ್ ಸೈಕಲ್ ತನಕ ಅಂದ್ರೆ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತದೆ. ಇಲ್ಲಪ್ಪ ನನಗೆ ಹಿಂಗ್ ಬೇಡ, ನನಗೆ ಎಡ್ಜ್ ಅಂದ್ರೆ ಟ್ರಾನ್ಸಿಷನ್ ಅಂದ್ರೆ ಏನು, ಹೈ ಇಂದ ಲೋಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ, ಹೈ ಇಂದ ಲೋ ಇನ್ನ ಮುಟ್ಟಿಲ್ಲ, ಲೋಗ್ ಹೋಗ್ಬೇಕಾದ್ರೆ ಆ ಟ್ರಾನ್ಸಿಷನ್ ಪೀರಿಯಡ್ ಒಳಗೇನೆ ಐಡೆಂಟಿಫೈ ಆಗ್ಬಿಡವಲ್ದು. ಯಾಕೆ ಇಲ್ಲ ಇಂಟ್ರಪ್ಟ್ ಅದೇ ಅಂತಂದ್ರೆ ನಾ ಈ ಬಿಟ್ ಒಳಗೆ ನಾ ಏನ್ ಬರಿಬೇಕು, 1 ಅಂತ ಬರಿಬೇಕು. ಅಂದ್ರೆ ಅದು ಎಡ್ಜ್ ಟ್ರಿಗರ್ಡ್. ಇಫ್ ಇಟ್ ಈಸ್ 0 then it is level triggered. If it is 1 then it is going to be edge triggered. ನಾ ಏನೂ ಸೆಲೆಕ್ಟ್ ಮಾಡಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಬೈ ಡಿಫಾಲ್ಟ್ ಅದೇನಿರ್ತದೆ ಲೆವೆಲ್ ಟ್ರಿಗರ್ಡ್ ಇರ್ತದೆ. ಅದಕ್ಕೆ ನಾವು ಹೇಳ್ಬೇಕಾದ್ರೆ ಏನಂತೀವಿ, 4 ಮಷಿನ್ ಸೈಕಲ್ಸ್ ತನಕ ಲೋ ಇತ್ತು ಅಂತಂದ್ರೆ ಮಾತ್ರ ಇಂಟರಪ್ಟ್ ವಿಲ್ ಬಿ ಐಡೆಂಟಿಫೈಡ್ ಬೈ ದ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ಇಫ್ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ಹ್ಯಾಸ್ ಎನೇಬಲ್ಡ್ ದ ಇಂಟರಪ್ಟ್ಸ್. Okay, so this is going to be the TCON register, timer control register. Okay, mode 0, mode 1, whatever I have explained till now, that can be represented using a figure. The function can be represented using a figure, whatever the steps I have explained. So you can see over here what's going to happen. The on-chip oscillator frequency will be divided by 12 because each machine cycle will be having 12 pulses. So it will be divided by 12, right? And the clock frequency, the clock pulses will be available over here with the frequency, whatever is there. And it will be fed as one of the input to the AND gate. The another input to this particular AND gate is your timer run bit, which is present in the TCON register. Okay. So when here 1 and 1 comes, what's going to happen? The output will be 1. And whatever the count will be there in the THX and TL, that will be up counted. So with each pulse, the up counting is going to begin. When the maximum count is reached, for mode 0, maximum count is 1F, FF. Okay. So when that particular maximum count is reached, with the next pulse, the rollover takes place. Suppose if I am using it as for mode 1, 16-bit timer, then maximum count will be FF. So with the next pulse, the rollover takes place. Anyway, after 1F, FF or FF, with the next pulse, the rollover takes place. Okay. So when the rollover takes place, the particular flag TF, ಯಾವುದು timer 0 ಇರ್ಬೋದು ಅಥವಾ timer 1 ನಾ ಯಾವುದನ್ನ ಯೂಸ್ ಮಾಡೀನಿ ಅದು. So flag gets raised. It's going to become equal to 1 to indicate that the timer operation or the counter operation has reached the maximum value and is now equal to 0, 0. The content of TH and TL is equal to 0, 0, 0. So this is going to be mode 0 and mode 1 pictorial representation. Suppose if I want to represent the same figure for mode 2, then what you have to do is you are going to load only in the TH register. So the count is going to take place. ಯಾವಾಗ ಎಲ್ಲಿ ಕೌಂಟ್ ಆಗದಲ್ಲಿ ಬರೀ TL, ಯಾಕಂದ್ರೆ ಇದ್ರದ್ದೇ ಒಂದು ಕಾಪಿ TL ಕಳಿಸಿರ್ತದೆ. TH ದಾಗೆ ನಾನು ಕೌಂಟ್ ನ ಲೋಡ್ ಮಾಡ್ತೀನಿ, TL ದೊಳಗೆ ಅದು ಒಂದು ಕಾಪಿ ಆಗ್ಬಿಡ್ತದೆ. TL with every pulse TL content ಅಷ್ಟೇ ಚೇಂಜ್ ಆಗ್ತದೆ. TH content will remain the same. TL ಯಾವಾಗ FF ಗೆ ರೀಚ್ ಆಗ್ತದೆ, ನೆಕ್ಸ್ಟ್ ಪಲ್ಸ್ ಬರ್ತದೆ, ಅವಾಗ ರೋಲ್ ಓವರ್ ಆಗ್ತದೆ. ರೋಲ್ ಓವರ್ ಆದ ತಕ್ಷಣನೇ ಫ್ಲಾಗ್ ಏನಾಗ್ತದೆ, ಸೆಟ್ ಆಗ್ತದೆ, ಸೇಯಿಂಗ್ ದಟ್ it has reached the maximum count and now it is ready for the repetition of the same task. So this is going to be the representation of the figure. So when they ask you to explain the timer operation or the counter operation along with the figure, if you explain, it's going to carry the answer. Your answer is going to carry full marks.